Good afternoon, everyone. This is Dawn Marshall, and welcome to the third session of the Safer Sim Simulation Bootcamp. Just a little bit of housekeeping. If you could all type in the chat where you're from, just to let me know that everyone can hear me, that would be fabulous. I hope that you're all enjoying our series. We are halfway through after this one. And let me just advance. It looks like most people can hear me. Thank you for typing in. So this is the team of people who have developed this series, and I want to give a huge thanks to them. It wouldn't have been possible without their collaborative efforts, putting in both drafting and then providing feedback for all the webinars in this series. So thank you to the team for developing this project. We are indeed in the third webinar, and this one is scenario design, development, and testing. The next two webinars continue throughout the next 2 Tuesdays in April. We hope you'll be able to join us for all of them. This is an overview of what we'll be talking about today. We'll talk about moving from the experimental design, which was covered in the last webinar, to the scenario design. Then we'll talk about a little bit about scenario specifications and authoring, dependent measures, testing, defining your valid events, the importance of testing, and then sort of lead into the next webinar with a brief discussion of how it affects your protocol. So just jumping right in, one other thing I should say, that while I'm talking, please feel free to type questions in the chat box. I will try to monitor that box, that area fairly regularly, so that I can answer questions as we go along, if you have any. So it all starts with your experimental design. What are your research questions? And so what do you want to test? Is there a reason you would want to be in an urban or a rural situation? If you're looking at crash situations, where do crashes for the population you're concerned with happen? Do you need daytime, nighttime? Do you have the resources to develop those? There are other large questions like turns, like 90-degree turns at intersections. Do you need them? Is there a reason you need to study that, or can you avoid them altogether? And then you should also think about things about like how the roadway affects your data. For example, lane position during a curve, even a large radius curve, may be different than on a straightaway. And so are there aspects of your overall driving scenario, like the world you're driving in, that may affect the data you want to look at? And if it would, how would it affect that data? And then how important is that aspect? Another question here is, are there resources that already exist that you can leverage? For example, is there a driving world or database that you can use? Are there previously developed events that were used for another study that give you a starting place? And that you can investigate that by this list of criteria that you need for your study, and what actually meets what you have meets your criteria. And yet, even though I just said, are there other resources that you can leverage, I am not suggesting that you compromise on what you need for a specific study. What I'm suggesting is that you evaluate resources and then decide which ones are appropriate. And if a compromise is necessary, then you're making an informed decision. So the other questions are you going to have a practice drive? How are you going to lay out your drives? How close are things going to be? How many events will you have? And I'm talking about driving simulation because that's where my experience is. It's also the area, rather than pedestrian or bicycling simulation, where you might have a long drive. I guess in bicycling they can go a long way, but in pedestrians, they sort of simulators, they often cross the same road because walking a whole block takes a long time. But the first question is, do you need to give your participants practice or time to become familiar with the simulation environment? Do they need to become acclimated to braking and steering? This may be true if those are key dependent measures that you want to know that they're familiar with those systems. Are there tasks you're going to ask them to do that they need to practice? Are there instructions from a navigation system that they need to be accustomed to and learn how to follow? And this all allows them, participants, to make mistakes before you're collecting data. Another reason to include a familiarization or practice drive is that if you have someone who happens to experience simulator sickness or disorientation of some kind, you can detect that early, and you can then make a choice whether or not they're going to move on to your main drive. And the reason I say that is that when people are not feeling well, they do not respond and behave the same way they normally would. And so feeling ill can affect the data you're getting. And this is particularly important in small sample sizes, because if you get one person out of 8 or 12 who doesn't want to steer or brake because they're not feeling well, they could become an outlier in your data, and then you don't have the power you think you have. Another benefit of practice drives or familiarization drives is that you have a chance, the experimenters, the researchers in the room have the chance to confirm that all the systems are functioning the way you expect them to. For example, if you have an eye tracker, you have a chance to calibrate it and then confirm that it's tracking and collecting the data you want. If there are other psychological or physiological measures, you have a chance to confirm that everything is working as planned before you're collecting data, and that gives you a chance to fix things, if possible, if it's small problems, before moving on, rather than losing that whole participant during data collection. Now, we often get asked, how long should these familiarization or practice drives be? We tend to make them somewhere between 4 and 10 minutes, depending on how long or how many things we need people to become accustomed to, or how many things we need them to experience. But it doesn't have to be a separate drive. It can be a section of the beginning of your drive, if there are all of these things that you want to confirm are working properly, and that you want to confirm there's no sickness. You could just add a section at the beginning of your drive and then check in with your participant, and you know everything's going well, and you move on into the data collection drive. The other thing you need to think about very early on is the layout of your drives. How many events per drive? What do you need to set up of each event? Do you need lots of vehicles? Do you need lots of space or time? Or can they be fairly quickly set up and move from one to the other? Are they different enough that you want to move quickly? Are they similar enough that you want to put some time and virtual distance between them? And these are all questions you should be asking. So this is a photo of one of our teams laying out some event orders for multiple drives. They needed equivalent events across multiple drives, and yet they also needed them to not be predictable to the driver. So because a driver's performance may change if they can predict what's going to happen because they just saw it either a few moments ago or 5 minutes ago or even in a previous drive. So if you're going to repeat things, you need to be careful about making each instance equivalent to each other in the way that you need, the study needs them to be equivalent, and yet they need to be perceived as different, or may need to be perceived as different to your participants, so that you get the same kind of performance each time, unless of course you're tracking learning effects, in which case maybe the same event is exactly what you want. I do want to emphasize that scenario development and testing process and all these things that I'm going to talk about are really an iterative process. We've found that the best practice is to author one thing at a time, one part of a complicated event or one simple event, test that aspect, confirm that that's working, then add another layer or another event, just basically new aspects before going on. And what this does is it allows you to know that there was a working version. You tested that on Friday night, you know it was working. You come in Monday morning, you add something else, and then suddenly things aren't working. Well, then you know what changes weren't working, whether those changes themselves aren't working or whether they broke something else, so to speak, in your scenario. And so it's easier to identify what's not working when you always have a working version of something to move back to. I also want to emphasize the very unpleasant aspect is that we need to document. We need to document all the time and everything. And I often find that documentation seems like a little bit of a waste of time. There's always some time pressure, and there's some resistance to documenting as we go along. And yet, we never remember exactly what we did later. And going back to the previous comment about suddenly things aren't working, if we updated our documentation when things were working, when everything worked correctly, then we know what did work. We also know, if we've documented what we changed. So if we thought we changed something, but we actually changed something else, we can confirm that we actually changed what we thought we were changing. And also, this is another one, is that when we're writing reports and papers, it could be months, weeks or months, maybe a year after the development, that we're writing up this documentation. And so we have clear, reliable documentation to go back to when we're writing up these papers, and then even longer down the road when we're responding to reviewer comments. If someone has a question and you have really clear documentation, you can always go back to that documentation to answer their questions, and that makes things a lot easier. So here I am talking about documentation and scenario specifications. Again, I know that the text on the right-hand side of your screen is very small, and it's not meant to be something that you could read. It's meant to be an example of detail. That in specification, what you really want are all the details you would need to, one, answer any question anyone would ever have. But that includes if someone, like in your lab or somewhere else, at some point in time needs to recreate exactly what you did. And so not only do you have the specification that came from your experimental design and how you got there, but you have what you actually implemented. So you have reporting, you have troubleshooting, and you have replication and comparability that is supported by documentation. So please document everything. So now I want to move on to actual authoring the scenarios, and some questions and some things that have come up over the years. Questions about what aspects you control versus the aspects you measure. These are trade-offs. One example is time, speed, and distance. The image you see on the right is from a collision event, and we can author that event so that one of those things is constant and one of them is out of our control. And then the other one becomes dependent. For example, if we author this event so the distance is the same between the driver and the incursion vehicle is the same, then the timing of that event is going to change based on the speed the participant drives, and vice versa. If we want the timing to always be the same, then we're going to have to accept some variation in the distance based on the speed the participant drives. And notice that I didn't say we're going to control the speed, because we can define things in a nominal way, and yet it's very hard to ask or control what participants do precisely. In fact, that is often counterproductive to what we're actually trying to do. We want to know what they're going to do, and so by trying to control their behavior or their performance very specifically, we're limiting the range that's available to us. It's also key to define the beginning and end of your event. For example, in another study where we were looking at adaptive cruise control and different headway settings in different situations and how people understood it, there was a suggestion that we look at how many times someone or a participant disengaged the ACC by either pressing on the accelerator or tapping the brake. But they wanted to count throughout the whole 20-25 minute drive. And my question was, what does that count tell you? When is that a meaningful action? And so the beginning of and end of your event is really, the beginning is where your dependent measures become meaningful, and the end is where they are no longer meaningful to your research questions. And so for that particular ACC study, that count of number of times of disengagement wasn't really a useful measure, but segmenting it into how many times did they disengage on the freeway where the traffic was fairly free flowing versus on an urban street where the speed was lower, not a lot lower, but there was more traffic and more variability in speed. It became more meaningful. And then I'd also like to suggest that you include measures that confirm that your scenario is unfolding as planned. An example of that is just the timing of your event, as you see in the example on the right, where we can look at those things. We use log streams for that. But if we were had an in-vehicle task, for example, is it triggering at the right time? What's the time between the location or some other trigger and when it actually appears on the screen? Those kinds of things that include things that allow you to confirm things are going as planned. And this is beneficial in the testing process, but it's also beneficial when you get into your main data collection, your pilot, and then your main, because you get people in there, drivers do all kinds of things, and then you have this way of confirming, not just trusting that things unfolded the way you had expected or planned them to unfold. And if they didn't, then you have data to decide whether it was different enough, whether it's something you need to throw out and possibly why, or if you can make a decision about how much variance you get on whether or not it's still a good data. So sort of moving on from there, what do you need to measure? The dependent measures are what you're studying, and they're not something you already know. And so that goes with don't assume participants will behave the way you expect them to. For example, speed. If you instruct them on how to drive, please drive at the speed limit, then measuring speed, their speed, may not be a meaningful measure. So all of these questions go into your procedures later as well. But there are also some unexpected things that drivers can do. What about a two-footed driver, someone who presses the accelerator pedal with their right foot and the brake pedal with their left foot? Are you really is one of your key measures that transition time? And if that's so, can you use the data from people who drive two-footed in that way? If they don't drive the speed you think they're going to drive, you've got a posted speed limit and they drive 10 miles an hour above that speed limit, or 10 miles per hour below that speed limit, are you still getting the data you need to answer your question, or is that data different? And I'm not talking about data fishing here. What I'm talking about is identifying the boundaries of what are valid equivalent events. For example, if the timing of your event changes such that it's no longer equivalent to other participants' events, then you really don't have good data. So I'm not talking about fishing out, just picking and choosing their performance. What I'm talking about is what changes the drive or the experimental conditions enough that you no longer have comparable data. So going more specifically into dependent measures, they're interesting because of what they tell us. And there are lots of resources out there. I've shown a link to one of them. I do want to note that Webinar 5, Data Analysis, will cover a lot more of these resources. But it's important to look at your dependent measures as you're collecting them, as you're designing your scenario, and keep making that connection back to your experimental design and your experimental questions. And as you're designing your events, are you designing out the usefulness? Are you controlling something that you were planning to use to answer a question? Or the other way around, is something that you really needed to control now something that's fluctuating, and you're no longer answering the question you thought you were going to answer? You were asking. You can also ensure during development that you're going to collect the data that you need to calculate your measures. Now, I realize that some simulation platforms calculate measures and some don't, and yet that also means that you need to be clear how your measures are going to be calculated. So nothing is worse than not understanding those two things. It's like not collecting the data that you need for a key measure because you didn't realize it wasn't being collected in some way, or not understanding how it's calculated when it's calculated for you because you think it's one thing and it's actually another measure, similar measure, probably if they're using the same names, but understanding how things are going to be calculated and that the right data is being collected is key to getting the data you think you're going to get. So, I already gave you the example of the number of accelerator presses or brake presses to turn off an adaptive cruise control system. But I also wanted to talk about other things like measures that are measured at a point in time versus over a period of time. For example, if I want to know someone's speed when a vehicle becomes visible, that's at a point in time. If I want to understand how some input affects their speed over a period of time, that's not the same thing, and yet we're both are looking at speed. And so you need to really think about, do you want a point in time or over a period of time, and why are you going to want those things? And this all goes back to your experimental design and your experimental questions. But it also affects how you design and develop your scenarios. So to ensure that things are being collected during that period, if there's a period of time, putting markers in your data stream for when that period of time begins and ends will greatly help you later when you're doing your data analysis. Also, are you aggregating like the mean, the minimum, max, standard deviation over a period of time, or do you want like a response time? So these are all things that there can be very many related measures, but you want to carefully think about which ones you're using. And then a little bit more about defining valid events. We've talked about that for a few moments, but here I want to talk about what will break your scenario. For what range of participant behavior will things continue to go as planned? And this is different than here than where I was talking about earlier, like, do you have still an equivalent or comparable event? This is just plain things go awry, is what I'm talking about here. And then, of course, for what range is meaningful, which is back to what we were talking about before. But is there a speed at which participants can drive that an event simply doesn't happen? Or it happens, but it doesn't even appear to be the same event. If they're driving so slowly and a vehicle pulls out in front of them, but it's so far in front of them that it's not really even noticeable or meaningful because of how slowly they were driving. If they're driving really fast, do they get in front of that vehicle before it can even pull out in front of them, and therefore the lead vehicle you're counting on isn't even there. So these are all things to think about when you're designing and testing your events. And I would say at this point, we're defining valid events. You probably have versions of your events, and these are things you need to think about while you're testing. So how can you break them? And I will say that the author or developer is probably not the best person to be doing this kind of testing, because they designed it, they've programmed it, they know exactly how things should unfold, and just by their nature, they're going to tend to perform in the way that was intended, the nominal case. But then also, when you start understanding these things, you need to start thinking about how these things may affect your procedures later. How will you instruct your participants or not instruct your participants? What kinds of things may affect the way they perform during your scenarios? And so finally, after all of this, I'm talking about creating your scenario. So part of the reason, or the reason, that this slide is so far into the presentation is that all of these things that I've talked about are things you can think about before you even start creating your scenario. They certainly should be thinking things that you're thinking about during your development process and your testing process. But the actual creation of your scenario isn't the only aspect. In fact, in the end, it's a key aspect, but it may not be the only. It is certainly not the only key aspect. And here I'm going to advise you to get other people to look at your work. Give your specification to someone else to review to make sure it makes sense. have several other people experience your scenario so that you can see it with different eyes if you're the developer, but also so that you get different people who naturally perform differently, and you can see it. And also, they're going to notice things that maybe you didn't because you've seen it several times, and this is the first time they're seeing it. If you're new to scenario development, use resources. Talk to other researchers in your lab or other researchers you know. If it's possible, look at someone else's scenarios or code. They may have solved problems that you don't need to solve yourself. They've already figured out how to get this piece to do that action on this timing. And so you can look at their code. Even if it's not exactly the same, you can start to understand their approaches to things. And once again, be iterative in your development. That start simple and build and test along the way. So now we're talking about scenario testing. And there's a few questions. Do the scenarios, you think they're done, you're ready, do they conform to the specifications you originally wrote? Now, those specifications were probably based on your experimental design and your experimental plan and those questions. So going back and confirming, even when you think you're done, do they conform to the specifications? Do your specifications still meet your study requirements? If you've updated them, if you've tested, do they still meet your study requirements? We've been talking about this the whole time, but test, and retest. We've just mentioned that the author is not a good tester. You need a naive person. And then look at the data. So this is something, looking at the data is something I'd suggest you do from the very beginning. It always seems like the next thing. But look at your data. Look at all the dependent measures that you're going to look at early and often. Look at those confirmation variables that you're putting in early and often. Ask other people to come in and ask them to try to break your scenario. Ask them to drive as they imagine different people would drive. I could drive as if I'm not feeling well, and that's going to be different. I might be slower. I might just naturally be a more careful driver than someone else. Someone else might be a more aggressive driver. You want to see a range of drivers in your testing because you're probably going to have a range of personalities and driving styles in your study. And so the more you can test this and understand how this affects your scenario, the better. Once again, look at those confirmation variables. Make sure that things are unfolding the way you plan for them to unfold. Look at your dependent measures to see when you start getting some variation in them. Make sure you are getting some variation in them. That's a huge thing right there. If you get exactly the same value over 2 drives for a dependent measure and you're going out a couple decimal points, you may have a problem. You may have a problem in your scenario. You may have a problem in the way it's being calculated. But look at the data. So if you look at this diagram, we started with the experimental plan. We went to an event specification, and then we authored, test drived, evaluate, updated our specification, and we worked on that process. And here I'm saying that you should definitely go back to your experimental plan and then confirm all the way through right to your dependent measures and what you think you're going to be analyzing, because in any process things shift, and you want to confirm that you're still getting what you know you need for your study. Okay, and I also want to emphasize that this is a process that I'm talking about that is all before pilot data. This is internal testing is what I'm talking about. It seems like a huge process. And it is a process. It's not as simple as developing something and then putting some pilot participants in it. Because when you do when you go straight to pilot testing without doing all this internal testing, it's very hard to know what's wrong, or if things aren't coming out the way you want them to, what's wrong based on those other the pilots, because it's not nearly as controlled as the testing environment. Not only that, if your pilot data isn't what you need for your main, then you have to repilot. And so it can really save you a lot of resources and time if you iteratively test during your scenario developing. Even though it's one of those processes that seems like it takes a long time and a lot of resources to get done, it has been my experience that it actually saves you time and effort in the long run. To get to a pilot data collection where you think you're absolutely ready for your main data collection, because those people who come in and are completely naive except for what you tell them are going to behave in ways that probably none of you drove. And so then you're going to find even new things out about your scenarios, but you don't want to find out things then that you could have found out earlier. This is another question about scenario testing, is does it feel real? So of course we're in a simulation, and we use simulation because of its safety benefits and its repeatability, and so it's not video real, but do the other actors or agents in the scenario behave in a manner that is going to feel real to the other to your participants? Does the car in front of them accelerate and decelerate in a way that's reasonably realistic? Do cars turning, do the turning paths, do they look real? All of those things are going to affect the way, on a very subtle basis, but affect the way people respond to your events, and you're going to get better data the more real it can feel. So this also tell you that we've had studies where we got a version of the scenarios that technically met our mathematical specifications. All the physics was right. But then when we drove them, it just did not look like something we felt would happen on the road. And so then we had to change things, and we needed to understand what we needed to change. And then also go back and change our expectations and go through that whole process of what does this tell us, like how are we going to answer that question, how does this affect the way we can answer the experimental questions and the specifications, until you get to the point where you are answering your questions and you have the best possible scenario you can have, and that people aren't going to come in and say, that was totally fake, or this feels totally fake, because if it doesn't feel realistic to them, they're not going to behave as if it's a real situation, and then your data isn't as meaningful. So we're drawing close to the end, but I do want to talk about how all of these things affect your procedures. Do you have if there are technical issues during your data collection, what are you going to do? And the unexpected participant actions. What is the research you're going to do? And there are lots of options. You can have them restart from the beginning. You can have them restart in the middle. You can just decide to tell them everything's over and replace that participant. But I want to discuss some reasons you might or might not want to do that. any of those things. For example, if you restart at the beginning, take into account what they've already experienced and already seen. What they've already seen is going to affect what they expect to see and how they respond to those things. If you restart in the middle, can you do it in a way that seems reasonable? What about the event setup? Can you get that event reset up in a reasonable way so that it is comparable? If you decide to replace the participant, was this a technical issue or something they did, and how are you going to document those things, and how often do you really think it's going to happen? For the unexpected participant actions, is this something that you can now instruct them on how to do instead of, or provide additional instruction? And how might those instructions affect the way they drive? Does it, the example I've given before during this talk is the speed limit. If you ask them to drive closer to the speed limit, or please drive at the posted speed limit, then how does that affect your measures? Or is there another way to do it? Is there, say, ask them if, would you normally drive 55 miles per hour in a 35 mile per hour zone? And if they say no, then what you've done is you've drawn their attention to it without instructing them. Now, I'm not saying that's the perfect answer. I'm saying it's an example. So I've been talking a bit about procedures, but one of the reasons is you want this stuff to be consistent. It's very important that your experimental protocol is consistent. And the next webinar will talk about procedures and protocols, but these things are important when you're developing your scenario, because you have to think about, during your scenario development, how you're going to deal with unexpected situations. Like, what if some equipment goes down? What are you going to do? Is that data key? Can you restart it? When can you restart it? What if the participant turns or does something else in a completely unexpected way? We've had people say, oh, can I go down side streets? As they were turning down a side street that led to nowhere and meant that they weren't going to reach the place where we really needed them to be. Or is that, did you design things so that they could just drive around in the world and you could trigger things as you needed? What if they drive too slowly or too fast? We've talked about that. But it's important that the researchers interacting with the participants know how to handle these situations, that all the same information about their experience that they're going to experience and instruction on how to do things is consistent, including answers to the questions you can anticipate. And are there ways you can design your scenarios so that some of these unintended things have fewer consequences? I mentioned the loop. Can you create a loop so that they eventually get back, or maybe not too long, but they get back to where they needed to be? Do you need to develop restarts? It's also important that staff know how to fix the small issues, and all of this testing will help you discover what those issues might be. Does something need to be reset? Does an iPad need to be logged back into? Those kinds of things. But and you might think of that as pilot testing, but I really think of it as prior to pilot testing, because remember, I talked about your collecting all the data you're going to need and examining whether or not it is what you expect it to be and the things that might cause it to not be collected or not be what you expected it. Knowing when to keep going, when it's a small issue and you can either work with it or fix it, or when to postpone. Say, just admit there's an issue with the equipment or the simulator, and we'd like to reschedule you before they've experienced too much of your scenario for it to be comparable to other participants, or when you need to really just end a specific person's participation. Are they being so non-compliant that their performance is just not comparable? An example we had was a teenager who really wanted to be in the study because they wanted the money, and I'm speculating on their reason. But they got bored, and they decided with each successive drive, there were 5, they drove faster and faster and faster. And in their final drive, they ended up driving a little bit, but over 100 miles per hour. And so knowing when to just end their participation is also important, or when the experimenter is going to flag that participant as the data is no longer good. And you're going to know that from your specifications and your testing, and knowing when the data becomes too different, when your events are not comparable anymore. And all of these, of course, feed into the procedures and training you give your staff for how to run the scenarios, run the experiment. And while that's going to be covered in detail next week, it's a process that you're starting very early on, because you're still working on this whole time. You've been heading towards this goal of good, usable data. And so that was my lead-in to next week. I went through this material pretty quickly. I'd like to remind people that the next webinar is next Tuesday, April 23rd at 3 p.m. Central. But before we move on and end, I would like to open the floor to any questions. If you would type questions in the chat, I'll just give people time to do that. And while I'm giving people time, I'm going to put up a slide, which is a reminder about the Road Safety and Simulation Conference that is this October. It will be here in Iowa City, Iowa, and I hope some of you will be joining us there. So, any questions? I see some people are typing. So the question is, if when can you use pilot data as actual data? Thank you for asking that. I would say that when you move from pilot data, when you've collected the pilot data and there are no substantial changes needed before moving on to actual data, if that's your question. So you've developed all of this and you've gotten an outside participants come in, that's what I would call pilot data. And if you've done this development process well, and they didn't do something that's so unexpected that you couldn't have prepared for it, then if there's no substantial changes. And by that, I mean if everything you do still meets all your specifications and your needs. Yet, so for an example might be there's some oncoming traffic that you didn't really like during your pilot, you didn't really like where it occurred, and so you changed the timing of when that oncoming vehicle comes down the road, but you just thought it was a little close to your event, and so you make sure that they pass that car sooner, so they're not looking at it when you really want them to be looking somewhere else. That might not be a problem change. But if you find you have to like change event timings or completely reauthor something, I would say then you're probably looking at a second pilot. It all depends on whether or not you're making substantial changes. And I can't really define substantial for every study. But what I would say is if it's a change that would affect your participants' performance, then I would say you need to at least run a few more pilots to confirm that everything's running as you expected. Did that answer your question? Yes. It looks like someone else might be considering typing a question. Oh, there it is. Not a question, but a comment. I read one study abstract that reported that sim sickness did not affect driving performance. So I haven't read that study, and I would say that the report of simulator sickness at a point in time may not have affected driving performance at another point in time. And here's an example. You have a 20-minute drive, and the simulator sickness is brought on by coming to a stop at the very end of that drive. And the data you were interested in was 5 minutes before that. And it's just that final braking to a stop that brings on the sickness, and you don't ask about sickness or how they're feeling until the drive ends. And then in that case, I would say that simulator sickness did not affect that data. There have been other studies that have said that people, and a lot of anecdotal experience, that people resist steering when they're feeling dizzy or have stomach issues, that any of the stomach issues people ask about, and also that people resist braking. So their brake response time may not be the same, and their braking profile may not be the same. If you have a copy of that study, I would be very interested in reading it. Because that's not true of my experience. Thank you. Thank you. They say they'll look for it. And Carol says she would like that paper too. I tell you what, if I get a link to the paper, I will send it out with the video recording of this presentation. Okay, a lot of people would really like a copy of that paper. I would also suggest that you read other papers as well. I mean, I imagine that there are many things that affect simulator sickness. And as I started out talking about, if you can eliminate things that create it, then you don't even have to, this problem becomes less and less. Any other questions? I'm just giving some time for people to type. Still looks like someone's typing, so I'm just giving that some time. So Kevin says he believes sim sickness can be erased by updating the sim. Kevin, I would agree with you that there are certain say, I don't want to really use the word fidelity, but aspects of your simulator that people can upgrade. Simple things like the temperature in the cab can affect simulator sickness, but I think you're probably talking more about better visuals, better match between the visuals and any motion. Carol says field of view. And I think all of those things can affect simulator sickness and affect different populations in different ways. So we've got a couple people typing comments. Ambient temperature, yes. We have found that ambient temperature is very important. We actually keep our simulator cab or room fairly cool, between 68 and 70 degrees Fahrenheit. And advise participants to bring a jacket. And the reason for that is we found that the sim sickness rate simply goes down when we keep the space cool, or should I say, it goes up when it gets warm. And so, that's key. While someone else is typing, I'm going to just add that another thing, if we know there are maneuvers that may make someone who may be a little prone to sickness more likely to be sick, we do things like hand out small bottles of cold water before their drive as just a courtesy. We don't tell them why. We simply give it to them. And many people who say no thank you then end up drinking it. And we have a comment that field of view is a complex issue. One study reported no increase in sickness beyond 140 degrees, and that study will be easier to find. Somebody comments that room lighting may affect it. And that is true. So this is a great conversation about a very complex topic that has many inputs. I'm trying to think. Another thing, and it's, I don't have a study on this one, but scents. Our researchers don't wear scents when we're working with participants because there are some people who are simply more sensitive to simulator sickness when there's a scent in the room, even if it's a subtle scent. These are little things. We have found that that the combination of field of view and motion has something to do, affects this. But I can't tell you where the field of view is. Somebody said 140 degrees. Yes, there it is. And you said that study will be easier to find. Can you share a link to that study, Pierre? We've got some people typing. Too much homework, but I'll try. Thank you. And so, no worries. If you can find it, that'll be fantastic. And I would be happy to share links to any works that people think would be relevant to the topic today, or any of the topics we're covering in this series. This is meant to be a resource for people to go to, and so if there are resources you feel would add to that and support people's efforts using simulation as a research tool, we'll be happy to share them. So I don't see anybody else typing at the moment. I'm going to give us just a few seconds so that if someone has another comment, they can start typing and I'll notice that. And in the meantime, I'm going to once again thank the team of people who developed these webinars and all the contacts. We worked as a team with different people leading each webinar, and none of this could have happened without that entire team. I will also mention that we did record this webinar, as we will all of them, and we will send a link to the recording to everyone who registered for the series. And I expect that link will certainly be out by the end of the week, but perhaps a day or two sooner. And that I'm looking forward to your participation in our next one. And I'm going to back up a little bit. Next Tuesday, April 23rd at 3 p.m. Central. So we've got one more person typing, but if that turns out to be a question, I'll read it to you. And it's a thank you, David. I've really enjoyed this. So thank you to everyone, and see you next week.